Hello. Hello. Thank you, Ali. Thank you, Matt, for that wonderful introduction. I haven't been back to Berlin for 6 years, and so I'm so excited to be here at, this is like my bucket list. It's the last of the main Go conferences that I've been able to attend to, so I'm so privileged to be here on stage. Now, as Matt kind of said, I've had a long affiliation with Go. We're very lucky in Sydney. Go and Sydney are very tightly intertwined, and so I got an opportunity to, I've been a Go developer at 6, 7, 8 companies that I've written Go for over the last decade or more. And the point of that is not for me just to big name myself, but this has given me a lot of experience to see Go in production, see it in anger, and form some pretty strong opinions about what I think makes good, readable, maintainable, and most importantly, testable code. And my goal today is to share, for your consideration, some of these opinions. So in that spirit, I settled on naming this talk the things that I keep repeating about Go, because it is a talk about the ideas that I find myself repeating, the patterns I find myself repeating, the ideas I come back to and re-implement across projects throughout my career in Go. And so broadly, we're going to talk about 3 things. We're going to talk about naming, we're going to talk about initialization, and we're going to finish by talking about helpers. So let's get started. I want to address the elephant in the room, which is naming. All the things that we can give names to: variables, constants, packages, types, methods, and functions. These are all the things that we name in our Go programs. And if there's one thing that I think we can all be on a journey of continual self-improvement, is to always be asking the question, always be obsessively fretting about the names that we use in our programs. Now, a lot of Go programmers, perhaps if you grew up in the era that I did when we started with the Go tutorial, and we kind of got indoctrinated into that Pike style of Go with its very short identifiers. And so we've all had or seen or been part of the flame wars about these Go developers and their gosh darn short identifiers. I mean, is there some way that I can put this to rest? Is there a one correct way to do it? Well, thinking on this, I prefer to follow the long-departed but certainly not forgotten Andrew Duran's advice, which was the best identifier is the shortest one that describes its reason for being. And let's work through some examples to explain what I mean. Because the important part is to put the important parts of the identifier at the front, not the back. You're not writing a thriller novel. You don't want the reader to be in suspense all the way to the end of the identifier. And this is also really important when you have more than one kind of that thing in scope at one time. And conversely, if you have a name that has very little meaning, you have an identifier that lives for very little time, this advice means it doesn't need a long name because it doesn't live for very long. So here's an example. The question from you, my audience, and out there in Radio Land, is naming the name of bool pointer and putting the type in its name going to make it more or less type safe? Okay. Is it going to make it more or less readable? That could be subjective. So here, all I've done is change the name of the formal parameter. I haven't changed the logic at all. Has this made it more or less readable? We could compare it to a third version, which kind of like leak code tries to compress all the code onto one line, but keeping that very descriptive, ornate parameter. Just which of those 3 do you think is the most readable for you? Now, this is a contrived example, but I think what I'm trying to convey here is that the important part is not the name of the parameter, but the logic instead. Ultimately, being consistent is more important than brevity or length. Let's look at another example. This is from a piece of code, roughly, that I work on. This is a completion package. It has a request type, and it follows the kind of ports and adapter style. So the first thing we do in our HTTP handler is we take the HTTP request and we convert it into a type of our own, and we're going to operate on that one. And there's already a problem here because rec, the HTTP request, has taken that identifier. So I need to think up a new one to give for the result of completion.newRequest. I chose crec because it was the closest. But if you look inside this package from the point of view of the author, it might seem more reasonable to call this just request. This is the completion package's request. Just call it rec. And what I want to show by this example is there's kind of a duality for Go programmers. Both you're working inside your package or you're working as the consumer of a package, because your view of the names differs greatly whether you're working internally or whether you're using the fully qualified name. And so I want to present an alternative that I've been adopting. And it kind of comes in three parts. The first one is that we just abandon the identifier rec. We say whenever we see an REQ, that's always a HTTP request. Always will be, always is. So we have to think up a new identifier for the result of completion new request, and we'll call it a crec. But the key here is that we use crec as the receiver and as the name of any formal parameter. So anytime you see a crec, you know that it's a completion request. And that doesn't really change whether you're inside the package, whether you're outside the package, whether you're a caller of it, or whether you're working inside it. Kate Gregory spends a lot of time in her book, Beautiful C++, talking about comments. She's got some wonderful things to say about comments. And specifically, the one I like the most is if you can give an identifier a good enough name, you probably don't need to give it a comment. It's self-descriptive. So here's an example of trying to test that idea. Here's a piece of code. The body of the function doesn't matter. All we need to know is just from the declaration here. Can anyone spot a problem with this? Jeff? It's redundant? Okay, the comment. But this function is called validate, but it doesn't return an error. So how are you going to explain, like how you're going to indicate that validation failed? And this was a clue to me that the name of the function might be wrong and the comment wasn't helping. Because under inspection, what this function actually did was flatten the nodes of the graph. So this is just a contrived example. Like in the real world, your experiences will be subtler. But what I'm trying to give you a whiff of is if the name of the function doesn't seem to describe what it's doing, then that's a smell that the comment can't hide. Like saying it twice doesn't make it any more true. Now, sometimes the opposite is true. Identifiers are so unimportant, they don't need a name. In fact, giving a name might be counterproductive because it just takes up space. So if we look inside the completion package, what we're doing here is that we're not going to JSON decode directly into the completion type. We decode into an intermediary type, and then we validate that and pick over that and take the bits we want. But that presents us with a problem. Like, what are we going to call this intermediary type, which isn't the request on the way in and isn't the final one? I mean, that's a kind of a struggle to think up a name for a thing which is not going to live for very long. And so we can just not give it a name at all, just use an anonymous structure. This type doesn't escape this function. It's never going to be seen to anybody else. So like, don't spend time creating another name like request client or something like that. You just don't need to give it a name. All right. So our brains, or at least my brain, is basically 99% animal instinct with like a little smattering of consciousness and neuroses on top. So it's my belief that anything we can do to reduce the load on that fleshy little bit on the top, we should do. I talked at length about names for better designs. So the second part of this story is talking about the actual flow of statements. Because I'd say the biggest change in my coding style is that I'm developing a real aversion to the if statement. It could be summarized like this. Like, if is bad, then else is worse. And what that means for me is that every time I see an if statement in my code, I want to hide it. Every time I see an else statement, I want to change my code to make that go away. So let me unpack this a bit with some examples. Now, I'm sure there are some people in the room who are sad to hear this, but like Go doesn't have immutability. But that doesn't mean we can't pretend it does. Here's a really, really common scenario. You will encounter code like this throughout your career. You have a thing, and depending on the environment, it's either the real thing or the mock thing. But at the point at the top there where thing is declared, it's neither a mock or a real thing. It's nothing. It means that if this code is refactored or rewritten or churched up in any way, we could end up not properly initializing thing. Now, removing the else is pretty straightforward. What it means is that by default, we always initialize thing to a mock, and then in production, we override it with the real thing. And that's good, because that means if someone monkeys with this conditional at the end there, at least thing will always be initialized. Now, we're here in Germany, so we should talk about performance. And you might be wondering, if making a mock thing is expensive, then in production, not only are we making a mock thing, but we're overriding it with the real thing. Like, that could be quite expensive. And now, this is arguably context dependent. Like, if this is during setup, it's probably not a problem. But if this is happening per request, then yeah, I agree with you that we probably don't want to pay that kind of cost. Now, it's probably no surprise to see that to solve this, I've created a helper function, and I've pushed the conditional in there. And you might be thinking, well, that's a very, very smart thing for an Australian to do. You haven't fixed the if, you've just hidden it. You've just moved it somewhere else. But I'm going to pitch to you that this has several concrete improvements already. The first one is that now thing, from the point of view of the caller, is always initialized. As the reader of the code, you don't need to know about what the thing is or how it's created. All you know is that there will be a new thing, and it's conditional on the environment. More importantly, new thing is now a free function. We can wrap a unit test around it, rather than trying to test it in the context of its caller. New thing is now clear about what it's doing. Rather than being a stanza of code, it stands alone with a name that says, I create new things. And lastly, because we're not using this lazy initialization idiom anymore, it's now very clear that what new thing does is a selection based on the environment. Now, our lovely MC, Matt Ryer, coined this term, keep to left. I really love this. Even though this is a right-hand drive country. You probably know this as guard clauses or preconditions. I mean, whatever name you give to it, the idea is the same. You want to keep the happy path, the success path, as close to the left-hand side margin of your editor, rather than letting the code kind of disappear into a sea of parentheses off to the right. Now, as an example, I could have written new thing like that, which indicates that production is the expected case, and all other cases are exceptional. But in keeping with my dislike of if, because this is a selection, I prefer to use a case statement. We're selecting a thing based on the environment. And that means that when inevitably new environments come along, extending this is going to be much more straightforward. We just put a new case in there. Another Matt Ryer gem is the main.run pattern, which is one of my favorites. If you haven't seen this, well, actually, let me explain what the problems are first. So main.main is the most important function in a Go program. Every Go program has one, but it's the weirdest because it's the only function you can't return an error from. It also is really hard to test because it carries with it all this implicit state. The OS environment, standard in, standard out, any flags, any globals that it knows about. All of these things, which if you wanted to test your main.main function, you have to carefully arrange and then put back at the end of the test so nothing notices. And like all of that manipulation of global state is just grotty and horrible. And also doing that means that you can't do it in parallel because there's only one global environment. There's only one os.args. And generally, that main.main, like setting up your entire application and tearing it down, is quite slow. So not being able to do that in parallel in testing is a bit painful. But the last one is that because most programs start off with doing kind of all their setup in main, it turns out that your main function is the most error-prone. The example which inspired this slide was we had a problem where the logger didn't initialize, and then attempting to use said logger to write that we couldn't initialize it caused the program to crash. Now, applying the main.run pattern is very straightforward. You just take all of the implicit state which you used to access directly, and you pass it into a new function called run. If that returns an error, you just print the error out and exit. Simple, 6 lines. But what this means is that now your run function is just a regular Go function. You can follow the keep to the left pattern of working through your preconditions, building up your state as you work down the page until you get to kind of the main loop of your application. And if there's ever a problem, you just return an error, just like you do from any other Go function. And that means you can test it just like any other Go function. You can test it in parallel just like any other Go function. So in my current project that I work on at GitHub, we have a very important check. This is, has the user given us permission to record their telemetry? If they have not, then we must send special headers upstream to our APIs to say, you're not allowed to record this. And you might think that's how it's written. But it actually looks like this. Now, why would I make this kind of Baroque mess here rather than just a simple statement? Well, part of the reason is that irrevocably bad things happen if we record users' telemetry when we're not allowed to. Like, that's a very hard problem to undo, so we never want that to happen. But more importantly, by moving the logic into a helper, I've given this pattern here, a name. And in fact, I've given it 2 names. Do they permit telemetry or do they deny telemetry? And of course, because it's a function, we can now wrap a test around it. The second reason I've come to prefer this style is that I want the conditionals to scan well. Let's compare these 2 examples. If not completion request.stream versus if completion request.stream is false. One reads easier than the other. And of course, it would be even better if we wrapped a helper around that, and then we can give the conditional a name, and also avoid using negation. All right. My dislike of greater and equal to. So anyone who works with HTTP is always looking at the status code, and the general agreement is below 400 is all good, 400 and above is a failure. So you might write code like this. But I'm going to put it to you that this is perhaps preferable. Now, because in the first case, as the reader poring over this code, you actually have to consider 2 things. Is the status code greater than 400, or is it equal to 400? Versus the second case, where you just ask, is it greater than 399? Now, this isn't a lovely whole number. It doesn't scan, rhyme very well, but it's one less thing to remember in your head. So why am I spending so much time banging on about these little small details? Well, because of this. This experimentally is the number of things that the average person can keep in their head, in their short-term memory. 7, give or take 2. So, and this implies to me that if the number of distinct facts you can keep in your head is limited to quite a small number, then that limits the size of the problem you can kind of be thinking about at any one time. And so when you're writing a conditional, you want to say is greater than or is less than, not is greater than or is equal to, because that's 2 things, rather than just remembering 1. Let's dig into this more and talk about helpers a little bit more. By this point, you've probably figured out that my style is heavily weighted towards using helpers. There are some reasons for this. Helpers allow you to give names to anonymous patterns. Helpers allow you to push conditionals down the stack, out to the edge, right, out to the edge of the graph, and then it's going to make them opaque to the caller. They don't need to know how that logic works. But at the same time, it's going to make that testable for you, the author. Let's do a few more examples to drive this point. I think it was Uber that probably made the first version of this. There are dozens of these kind of pointer packages on gopackage.dev. They all basically look the same. It's just this, which is you pass in a value, you get the address of that value. Why would you need such a thing? Well, basically protobuf is the answer. Because in Go, it's very easy to take the address of a variable, but it's not easy to take the address of a value. In fact, you can't. And so if you have some kind of structure that requires a pointer to an integer, then you have to do this construction here. Now, using this kind of pointer to helper lets you dry that up a little bit. And what you've done is given a name to this anonymous pattern. Like, if you look at the first version, you can imagine for every field there, you would have to declare just a variable just so you could take its address. And you would imagine some newcomer who was not au fait with how protobuf makes you use pointers for everything would be like, what is all this? Like, why is this? Versus this, which you are initializing and declaring right there in line. Now we can take this a little further. This is from my long unloved ActivityPub project. And ActivityPub deals entirely in JSON. Everything is JSON in, JSON out. And so I have a package called to and a JSON wrapper, which if there are any Rubyists in the room, this is similar to the way that you can say just return the body as JSON. And so in the helper, in the handler, you can just say return to JSON anything that can be JSONified. It's just a nice kind of nicety. And you might be thinking, well, is that any different to just making the encoder and then encoding the map? Like, they're virtually the same. But did anyone spot in this version that it forgot to set the content type? So this leads to the question, is to a good package name? And my argument to you is that, well, it really depends on the context. I don't think creating your own to package and pushing up to package.go.dev is possibly the most winning idea. But inside the internal namespace, inside your packages, I think there's a great deal of, this is a great fit for creating new nouns and new verbs to extend the language you use inside your project. Let's do one more example. So here we have a little iterator that's taking the first element of a slice of choices and returning that. And to do that, we can write it like this. We can write it like that. We can't write it like this, unfortunately. Does anyone know why? It's just one of those things in Go that an L value can't be a field. But if we instead take this pattern and we make it into a helper, we can do something like this. And then applying it, we can just say this. And I really like this because it's removed all those temporary variables and scrobbling around with taking the first element and keeping the rest. And now we're just directly initializing choice part with the first element from the choice. And if you like that, you can take it a little bit further. You can make yourself a little list type and use it like that. And when I started using this, I thought this would be terrible because list of t wouldn't interoperate well. But it actually downcasts well into anonymous slice of t. So it actually isn't as viral as you'd think. And if you really get into it, you can start taking things like the append idiom and making a push. And this was a great benefit because I was transliterating some Python code which has these kind of affordances. And so to be able to use the same words that the original author of the Python code helped them understand the translation. Now, I think all of us work with microservices these days, and so it would be commonplace to deal with a request which is issued to you and then cancelled, like taken back, like, sorry, I didn't mean to send that to you, I'll take that back. And so you kind of end up with a lot of this code, because context.cancelled isn't really an error. It's not really an error in the same way that when you read from a file and you get I or EOF, that isn't an error. It's just a signal to say there's nothing more to do. It's just a cost of doing business. But the problem is that context.cancelled is an error, and so you end up with code like this filtering it out. To say, if I was cancelled, that's fine, just call it nil. And so we can wrap it in a little helper like this. And I like this because it gives a name. The caller can now see we're ignoring the context cancellation, rather than this little idiom here. Everyone here writes functional tests for the HTTP APIs? Show of hands. Okay. I would prefer to see more. So this is your classic test. You issue some request, you check that it didn't fail, and then you start going through the properties of it. Was the status okay? Was the body okay? Alrighty. But in the case where the status is not okay, the reason that it failed is probably going to be in the response body. So we probably want to log the response body when we report that test fails. So we could do something like this. Can anyone spot the problem? Well, one of the issues is that arguments to any functional method call are evaluated at the time the call happens. So even before the require equals has checked whether the status was okay or not, we've already evaluated all these other fields, which means that dump body is being called. It's consumed the request body, whether the request failed or succeeded. So that can be quite confusing, and it certainly was when I went later to actually look in the response body and found that it was blank. But we can easily fix this. We use a method to defer the evaluation of that. So in this form, dump body is evaluated, but the string method is only going to be called if required equals fails. And it goes into its kind of printf behavior, and the %v's evaluate their arguments, and that causes the string method to be called, which is going to cause the dump body. But in all other cases, the body will be left untouched if it's in the successful case. All right, let's round this off. Because when I struggle with a programming task, it's in large part because I don't have a strong conceptual understanding of the moving parts. Like if I can't visualize the problem, then I can't manipulate it. And the opposite, like the solutions that I'm most proud of are ones where the data model and the actors were so well defined that making additions and improvements just felt like coloring around the edges, just filling in the empty pieces. Because naming is everything. It tells you everything about your program, because clunky names, if you have contradictory prose, it's telling you where your design needs work. I mean, fundamentally, if it's hard to talk about, it's going to be hard to use. So, and additionally, if you need to clarify each of the declarations with a big comment explaining how it works, then that's a sign that your design is pleading with you for refactoring. Andrew Duran's rule: the name should be as short as possible and no shorter. A short name takes up less space on the page, it takes up less space in your head. Put the unique parts at the front, not at the back. And name the receiver and the local variables consistently. And lastly, name your packages after what they can do for you, not what they contain. Aim to initialize your variables once and only once. I mean, as I said, we don't have an immutability in Go, but that doesn't mean we can't pretend like we do. Follow Raya's rule, keep to the left, return early rather than layering on if-else brackets and continuing on to the right. If you're doing a selection, prefer switch rather than nested if-else. Importantly, don't repeat your logic over and over again. Put it into a helper which gives it a name. At the end of that, you're going to have fewer conditionals in your business code. And you can push all that testing out to free functions, which are going to be much simpler to test. And you can extend the language of your project with types and helpers to be clearer about what your code is doing. The more helpers you write, the less temporary variables you're going to have in your program, because you just don't need them. And this means that the identifiers that do remain in your program are going to live for longer. They're going to have wider scopes. They're going to be more important. And so they're going to have descriptive names. Because I believe that the language you use describes a problem. It directly influences how you think about the problem. This is the Safier-Whorf hypothesis. The language you use affects how you think about it. So look for clunky semantics. Look for inelegant prose and ask yourself, if this could this be improved if there was another noun or verb in the arsenal for your program? Thank you very much for your time. Please enjoy GopherCon.